Right. Hello. Good morning. I thought I would do let's see. I would do a short stream on some updates. I've done a lot of stuff on the project. Yeah, so basically the whole thing here, maybe we can look at the docs here. I really wish there was a better experience in terms of, maybe there is, like to read README in VS Code or Markdown files, I mean. Like have a proper, like if I click here, I can't like go back again. Yeah, it's interesting. Anyways. And then I have to do this and this and this. Kind of annoying. Anyways, so yeah, I'm gonna run the project. Let's build. Did I have a node? Oh yeah. Let's see. Just let me get it running here. Oops. Oh no. Wait, what was this? Oh yeah, but we shouldn't have that. I was just playing around with dependency injection. So sorry, I should have set this up first. Just let me get it running. Oh, what the hell? Why do you? Oh, come on. npm run build. Oh, come on. What's going on here? What did I do? Whoa, what's going on here? Cannot find module. Didn't I install UUID? npm run dev. And I don't want to open this. Why does it open it here? I want to share with agent. How do I move it to? Is this a new thing? Open in external browser. There we go. Let's see. Cool. Okay, back to it. So the whole point of this project is that when you work on very complex applications, it's really hard to do state management. And the question is, how do you do that state management? And all the tools I built this far, morning, Adam, all the tools I built this far. Oh, it's a setting. Interesting. Yeah, all the tools I built so far are very like, okay, let me build my own abstractions kind of thing. While ReactX is the complete opposite. Like, how can I create something without any abstractions? And then the question becomes, okay, what do you do then? Because React itself doesn't do complex state management very well and was never designed to do that. It's about UI state. And yeah, so you're kind of forced, if you want some kind of global state management, you're kind of forced to build these abstractions. Like Redux has its own abstractions, like all these solutions have their own abstractions. And the real only abstraction the real only thing you can do to not have an abstraction is to use classes, because they have a lot of information in them. That's important. I guess you could go with just objects, and that's also possible here, actually. Yeah, but anyways, the good thing about classes is that you can go like extremely complex or manage extreme complexity. So that's why I was exploring dependency injection as well. So the most complex web application that exists is VS Code. Like, I can't imagine anything more complex than VS Code. And the reason that project has been so successful is that they had some really, really experienced engineers. And they use like dependency injection, class-based. Like you should read the source code of VS Code. It's very, very interesting how they've been able to scale that project. And even though you don't necessarily work on a project that complex, it doesn't take long before the complexity of the state management becomes unwieldy if you don't use a specific tool for it. So it just scales infinitely using classes, because you can also do dependency injection. Because it becomes so boilerplatey and messy if you have a shit ton of like nested classes and a bunch of services and stuff like that, and you have to pass them all around, and it's just a friction of the developer experience. Anyways, so the point here is you create these classes, and the only API, the only surfaced API is this reactive function, and you only call it once for your root state, and then you're off to the races. And what I changed now is that it includes its own Vite plugin. So when you call that, it's gonna wrap all your components as observers, and it also manages the dev tool automatically. I didn't know that Vite had this hook for injecting dev tools, but that's super nice. So you don't have to concern yourself with like, oh, if it's dev mode, if it's production, everything's managed by Vite. And then you can exclude certain paths that you don't want to have observers, like stateless UI components, for example. Anyways, yeah, I guess that, yeah. And then the documentation is incredibly simple. It just emphasizes like the three, I should emphasize this even more actually. Maybe we can do that. It's state. Yeah, we should put, so you have, well, maybe we can do it opposite. So you have components, because that's what you know. So you have three things. You have components, you have state, and you have services. And this is a very natural way to think about managing complexity. It's like you have a component, it's basically just deriving all your state. It manages the UI. And then you have your state, which is like your main building blocks of the application. And then services represents access to the outside world. And those are typically what you would dependency inject in a very complex application, because that allows you also to do testing. Like you can very easily mock injected classes. So it makes it super simple to test your application state and logic. Anyways, we don't have to read all of that stuff. Maybe we can just look at the thing. So, yeah, by the way, I want to clean up the, let's see if we can do that. Let's see, center this. Yeah, let's see. Oh, where did I get, there you are. Yeah, and I'm still working on CodeSpark. I just made a change now. I'm going to publish, which where it actually is able to get diagnostics from the line you've selected or your intent command. So if your intent command is related to, oh no, that's not true. Well, yeah, it is true. Yeah, sorry. So basically the assistant can go and grab diagnostics from VS Code. So if you create like an intent command to like fix this type issue, or you just reference the thing and you ask about what the hell is going on here, it can go in and grab diagnostics. Anyways, yeah, how we thought about mounting state at certain component hierarchies. Yeah, and this is, I have a feeling like, because we're jumping between different abstractions and they all have their benefits and what's it called? Non-benefits. And I have a feeling, so the point here is that there are certain things you want to do that can benefit from having an actual abstraction. Like the first thing I did with ReactX was like, no, let's remove all the abstractions we built here, the query, the mutation, everything. Like this project has to be all about transparent reactivity. And then if you want to do like mutations and queries and all of this, you kind of have to just do programming at a low level. And then, or you can build your own abstractions, of course. But that also ties into, so something like we talked about, if you have multiple pages and you want to ensure that whenever you access the dashboard, for example, it should lazily instantiate the dashboard. That's also something you can do by just using a private uninstantiated dashboard and a getter or public getter for the dashboard, which then instantiates it when you try to get it and it's not been instantiated yet. Like you can do all of this stuff. But for mounting state at certain components, I remember we discussed this last time, that you kind of just create, I'm trying to remember the example. I think it was some kind of form or something. So when you, like, the question is who drives the state, right? Does the UI drive the state or does the state drive the UI? So if you want to open a form, do you first put the application in the state and create the form in the state and then the UI just arrives that state? Or do you like navigate to the form, and as part of that like UI state change, we go and create like some kind of application state out of that? And I think the trickiest thing is things like routing, I guess. That's always been a thing. I remember even for Cerebral. But there we decided, no, it's state first routing. So the router goes to your state management, and then the UI just derives that state. Yeah. It's very interesting. I can't remember. Do you remember? So you can always, so here you can also always use reactive. I think the problem with, so you can have, even in the, let's see, even, it's kind of cool. Look at, oh, make it a little bit smaller. So even here you see you have app state. If I had multiple reactive calls, you will kind of get them listed here. So you will kind of see all of them. So you can do like reactive on like just a completely separate class if you wanted to do that. I think the question with React is that you want to make sure that class is created only once. Whereas if you use strict mode, for example, then it will create the class multiple times. Or if the class needs to be cleaned up when the component unmounts, then you can't do that reliably with concurrent mode. So yeah, but you can definitely just use reactive and create a class. Yeah, exactly. Yeah, it's much easier to just say, no, your app is your classes, that layer, and then state first routing, everything happens there. Your UI is completely derived from that state management. That's a much simpler like model to make that statement, but then you will probably get into some friction points where, I should just use, like, why it would be simpler if I could just do this. But when that isolated thing becomes simpler, it just makes the overall mental model harder to reason about. Like, when should I do this as opposed to this? Yeah, it's interesting. Yeah, and this is so hard to reason about. Instantiation and disposal of instances in React is like, you can't do it reliably. But then you have like a simple form, right? The form doesn't need to be disposed. It's just, it will lose its reference and it will be cleaned up by the garbage collector. But if the form for some reason starts a subscription when you, well, that's a bad example, but has some side effect related to its instantiation, then you're in trouble. But you can also do things like, if you create a class, you never create a side effect in the instantiation of a class. You use a subscribe method, for example. So in React, you can still create the class, but then you use a use effect to subscribe to a side effect of the class. And then the side effect will never start if it's concurrently like cleaned up, because the use effect never ran. Or if the use effect ran, you're guaranteed that its cleanup will run. So I think that's really the pattern for that. Joining the state. It's the joining of the state and the correct spot to the UI, which I wish was easier. Yeah, exactly. Yeah, because that's also a side effect of having global state. Is like you always point to the root, or you can pass down substate as a prop to components, but then you have to continue passing it as a prop, which is the thing you don't want again. So it's like, I guess that's the tension. It's like, okay, you can always point to the root, and that means that in any component, that's going to be the same pattern. Like, you're always pointing to the root. And the cool thing about MobX is that that's incredibly efficient, right? It doesn't matter if you do that. But then if you have like a very nested component, it has to kind of point to the root and dot into something. It becomes like icky. But then if you choose to like short circuit kind of in one component, and you pass the substate as a prop, so you don't have to like do that dotting, but then you have to pass that substate as props deeper down. So you kind of have to evaluate when does it stop to get icky versus the management of passing things as props. It's very interesting. Yeah, I remember the 7 steps deep thing you were working on. It is really interesting. And then the other thing that I got hung up on was the null reference. Like, state isn't, so the initial state of the application doesn't necessarily have all the substates initialized. You dynamically do it as the general state of the application changes. So if you point from the root state and you have some part of your state that can be null or something, as when you point from the root, that thing will always be null or something. But you might consume it in a component that can't be mounted unless the thing is there. But from a typing perspective, if in that component you point to the root state and you dot into this potentially nullable field, then you have to like override that. So that's my friction with that. Which again means that, okay, but in the component that actually has the if statement, that decides if that's available or not, it should pass that as a prop. But then again, if that component now gets a prop with the actual field value, which is now instantiated, then that has to be passed as a prop down to the subcomponents again, which creates some friction. And it's very, very interesting. How we used passing as props. Hello from Norway. I'm doing good. Are you good? Yeah, anyway, so there is like friction for sure. And like the thing that I got hung up on was like just even the user, having an authenticated user. Like you don't know when you start the app if you have a user or not. That's typically a side effect that needs to come into fruition. But then the user is something you typically point to a lot in different components. And then you kind of have to decide how do you want to manage that? Do you always want to do a check if you have the user or not in every single scenario? Which was very fascinating at Code Sandbox, because the whole solution worked with anonymous users. You didn't actually have to sign in to be able to use the solution. So there it made sense to actually check. But there were certain scenarios that you could only access as an authenticated user. And then it becomes awkward that you have to like override the type kind of. But then you can do two different things. You can, as I said, when you mount that component that's only accessible by authenticated users, you do the check in that component. Do I have a user? Okay, let's mount it. And then you pass down the authenticated user. So that's available reliably type-wise in that nested component. But then again, as I said, what if that is a very complex component tree? You have to pass the user down a bunch. Another thing you can do is you can expose a property on your app state called authenticated user. And that will throw an error if you try to call that without an actual authenticated user. And that means the typing is correct, and you kind of know that which context you have the authenticated user or not. But the risk is maybe you don't know, and suddenly you point to that and it throws an error in a situation you don't want it to. Yeah, I'm curious. Like the interesting thing, or the perspective I'm trying to have now, is that what we're talking about now, this is the stuff that like AI is really, really bad at. And this is about like patterns and writing understandable code, writing scalable code, and all of this stuff, and reliable code. And the question is like, what is the remedy for, not remedy, but what is the type of tool you use to ensure these things or help users? And you can use helpers, or you can build an actual abstraction in the library itself, or you can document the patterns, like just because these aren't specific to, even though they come up in building an application, they are general programming challenges. So it's like, it's really good to, I think it's good to like express it in actual code. And again, as I said, you can always build your own abstractions. But yeah, anyways, it's fun to, yeah, like Rask UI is very much like as efficiently as possible create like an application. And it assumes all the primitives you want to make that happen. But I've found, yeah, it's a high abstraction. It feels more like a framework I guess, where you rely on those primitives and you're guided by those primitives. While here it's more like you're not guided by anything. You kind of have to use your programming skills to figure out how to best express things in a way that scales well and doesn't create confusing code or ugly looking code. So I guess it's almost like Rask UI is Legos and ReactX is more Technic Legos. Yeah, I wish I had a chance. By the way, very rainy weather in... Yeah, Adam, is it rainy weather in Australia? Yeah, we're having amazing weather today. It's like 19 degrees Celsius. It's awesome. We're gonna have a few good days. But yeah, I would love to like actually build an app in Rask UI. And I guess that's also like why like work on this thing when having Rask UI. As I said, that's kind of the pinnacle of how I envision like state management with UIs. But it's built on Inferno, while this is tightly coupled with React. So that's also a thing. Wait, the house has been leaking? That sucks. Oh, that's also interesting. Yeah, I wonder what's going to happen to like npm modules and everything when it's so easy to just generate the code you need. Yeah. That's very interesting. Anyways, let's demo. So let's look at the code for... we jumped all out. Okay, so this is the app component, and it just uses the app, and the app is just... So I have one class called JSON storage service, which just allows you to get and set local storage values as JSON. And then we have a to-do DTO. This is also interesting. Like when you go class-based, and this is also something that might not be as intuitive. There's like two paradigms of working with entities or resources. And that is to have a class where you bind all the relevant methods to the class. So for a to-do, that would be like the class would be to-do. It would have the ID, the title, and completed, but it would also have like a toggle method, maybe a remove method, and so on and so on. So that's one approach of doing it. And then the other approach that I'm doing here is that I'm just creating a to-do DTO. So that translates to the data. It's like DTO is data transfer object. This is what you actually get from the server, right? And it's JSON. And JSON is also what React wants to consume. So you just kind of don't create any abstractions over that. Just keep that pure from the server down to your UI, because your server loves JSON, React loves JSON. And then you, as we can see here, when I toggle it to do, you pass in the ID of it instead. And for building applications with a user interface, and you have like server data driving a lot of that, I think that makes things simpler if you kind of marry yourself to that mental model. It's cool to be able to like point to do.toggle, but it creates friction. Like first of all, you have to translate the to-do DTO into a class. You also have to wire up the dependencies for that class. So for example, the JSON storage service. If I were to add a to-do, I wouldn't do that on a to-do. So, but when I add a to-do, I want to sync the storage, right? But then inside the to-do class, I would also need the JSON storage service. because also when you toggle a to-do, you want to update the storage. But then it's a little bit weird because you want to kind of just update that one thing, like that one to-do, but the storage isn't based on that. The storage is all the to-dos. So it just creates all these frictions, I think, where it makes a lot more sense, at least for this scenario. And this is kind of the point. You just have to decide this yourself. But for me, it's like, okay, I have a JSON storage service. I have my to-dos where I use an object. So this is another part of it, but yeah, we can talk about that after. Anyways, so I have my JSON storage service, and then when I add a to-do, I just add it, and then I sync the storage. When I toggle a to-do, I just toggle it, and I sync the storage. That's all. So yeah, I think DTOs are really nice. And then if you have a form, you would if you have a form, you would pass the DTO into the form class, right? Anyways, so that's one thing. The other thing that I've reflected on a lot in all kinds of state management is like when you get data from a server, you typically get that as a list, right? I've yet to see a REST API that gives you resources as a map or as a record. But you want records. You really want records because they allow you to do lookup by ID, which is, as you can see here, when you toggle a to-do, when you can do a lookup by ID, it just becomes so smooth. But then if you want to display, and if you want to display a single resource in a UI, it's also really nice because you have the ID reference, you can easily look it up. But if you want to list resources or entities, yeah, exactly. But if you want to list them, you want them as an array. So the way I think about this is, okay, I have some to-do DTOs on my server. I get that in as an array. I don't actually get it from the server here, but what I would do is as I get them from the server, I change it into a map, and you can do that very easily using object from entries, to-dos map. And I guess you have the to-do, and then you do something like this: to-do ID to-do. So that's how you get a map of to-dos. And then that's a private thing because it's a lookup. And then you expose the to-dos as an array, where you do the object.values, and then you get an array again. And this array will only update if the to-dos map actually changes because of MobX. So it's just efficient out of the box. And then you have your map. You can very easily do reference checks and everything. So yeah, I like that model a lot. Simple. Anyways, so the whole point here is that services are just classes that, like, I haven't even demoed the dev tool. It's actually really cool. Anyways, so the point is that services is what connects you to the outside world. So you create an interface that makes a lot of sense, which gives the exact functionality that your app actually needs. So for example, local storage has, I guess, other methods as well. Yeah, in this case, like a simple example, it has clear and remove item, but we don't actually expose them because we don't use them in the app. Yeah, I'm ready shortly. So this interface is about connecting any like generic npm package, the browser environment. Maybe your app runs in Electron and the web. So on the web, local storage is synchronous. In Electron, it's asynchronous. So you can make it async, right? And you can change out the service based on the environment you're in, but your app doesn't care about that. It just has an asynchronous local storage mechanism. So that's what services are. And one thing that I think I've come to conclusion with now is that a service shouldn't be domain specific. So this is what I've been fiddling with a lot, especially using Firebase, is that I have a Firebase service that knows about the domains of your app. So you will kind of expose, okay, this is the collection for to-dos, this is the collection for users. It would actually be part of the service interface. But I don't think that's the way to do it. It should rather be, this is an interface for accessing collections in a nice way. And you can like combine that with automatic subscriptions and stuff just to make it super nice to consume it in the app. But it shouldn't know about specifically about users or to-dos or whatever it is. It's mechanical, right? Yes. And then you have the app state, and this is where it comes together, this is where you do, like, it's all about running actions and changing state. And then some of these actions might go and do something with the service, right? And if you do dependency injection with your services, if you have a bunch of services, a lot of dependencies to the outside world, you can do dependency injection. And that means that when you create your root state management, you can very easily mock the different services to write tests. So it's almost like your app state or like your state classes they don't become pure in the sense, like they do asynchronous stuff, but they don't actually depend on anything in the environment. That's the whole point. It's a self-contained living thing. And then your services represents, as I said, the outside world. So for a simple app, you wouldn't do dependency injection. Maybe you do end-to-end tests on CI or whatever. It doesn't matter for you. But if you have a really complex application, that's a really good way to do testing. Cool. And then you just do reactive, the thing, and then it works. So what's kind of cool here is that when this runs in development, it talks to this dev tool. So it gives you all the state that's being actually accessed. So the whole thing is lazy. So when you do new app state and do reactive, like put it in reactive, nothing actually happens. Absolutely nothing happens to the actual app state. It's only when React starts accessing properties on it, it starts lazily changing things into observables and all of this stuff. And that's what's being displayed here. So what's interesting about this is that it won't actually show you the full state of your application. It only shows you the state related to the current view. So as you start interacting, this state will start building up as you start accessing other stuff. Yes, and then we can try to add a to-do. Cool. Didn't I ask it to center this thing? Oh, anyways. So now I added that thing, and you can see that the map was updated. You can see it like this. That's kind of cool. And then we have a computed, like the getter that moves it into an array. So we have that. And if I click the thing, it changes its state, and you can see it reflected here. And then if I go to actions, we can see that I first added the to-do. We can see the arguments passed in. We can see that I changed the private to-dos by adding this thing. Oh, did it? Oh, interesting. And then, oh, interesting. I should fix that. And then it ran sync storage, and that called a service. So, so you can at like a higher, and the cool thing is I didn't do anything specific here. It's very interesting. It just understands it. It's very interesting. But what's also cool is that when you think about how your application works, you think about it from the perspective of like these core primitives. Like you have an action, which is really a method. And then you have the services. You don't care what's happening inside the services. And if the services are calling other methods and stuff, you don't care about that. It's just a service. But then if your app state calls another method, that's interesting information. And of course the mutations are like the primary interesting information because that's the user experience. But these are the things you care about. It's interesting because there's so much other stuff that you actually do in the code, but that's in service of this. So yeah, and you can go in, you can look at the thing is. So I guess, yeah, I just have to test something more complex than this. But it does handle, like, we even have computed in here. And the service thing. Yeah, so I guess we have to figure out something complex enough to really try it out. We should come up with some kind of fun project. Yeah, or I guess could just continue like building on the to-dos. But yeah, I really, and I think this is like when I talk about like not adding abstractions, it's a little bit in the context of AI. Like I saw this statement or heard this statement, like even though the AI generates the code, we still have to do engineering. And this is engineering. Like one thing is like big, like high abstraction engineering, which is, okay, are we gonna have a mobile app or a web app or what kind of technology are we gonna use? How are we gonna architect the relationship between moving data, or yeah, how are we gonna architect moving data between the server and the client and stuff like that? That's a high level thing. But then you have all the things we just talked about, like how do we organize our state? How does state move through the components? How are we going to express data fetching? Are we going to use suspense or not? All of this stuff. And if you... then the AI will be better at generating code for you, because you already made those decisions, as opposed to let's just shove it in and then let it run, and then it can do anything. Like there's so many ways to generate code. Yeah, so it's like creating the guardrails, I guess. But yeah, I guess that's it. I should get back to what I was doing. But yeah, I'm gonna fix this. Where was it? Oh, it was in here. When I clicked this one, it jumped down here, and I could still like collapse and expose it. But that shouldn't be possible. I should click this one. Cool. Yeah, maybe we can fix that immediately. So when yeah, this is also, I should have image support in this thing. Anyways, let's try, is it this one? No. What did I use as, oh yeah, I used my mouse button. So when I'm on an action that does a mutation in the DevTools, if that mutation adds an object, I can click the mutation to like expand that object. But when that object is expanded, I can also click the mutation to collapse it again, but I can also click the root curly bracket to collapse it. I shouldn't be able to do that. So there shouldn't be any clickable thing on the object itself. It should only be the mutation that toggles the expand and collapse, not the root object itself. Let's see. Yeah, so I completely vibe coded DevTools because it takes forever to build it, and I don't find it very interesting. Let's see. Yeah, we could have. Yeah, I don't really care about this at all. Oh, wait a minute. I don't want to even use this for it. Let's just jump into ReactX. And maybe this is how like YouTube and learning is gonna continue. It's actually doing programming on streams on YouTube, not necessarily to teach people, like say that you should do all the coding, but it's to show how do you want your AI to do code, right? Because AI, as I said, AI it's trained on a lot of shitty stuff, and can often, especially in the context of the specific thing you're doing, it can often make a lot of mistakes or just go down paths that doesn't scale and stuff like that. So yeah, that would be an interesting perspective of, yeah, let's see how you want your AI to write your code. I don't know. Yeah. Okay, cool. So if I go in here and we'll build it again. Boop, boop. Hey, and I click it. Oh, for fuck's sake. It didn't understand it. Did not work. The highlighted root here should not be clickable at all. Or was it just... Yeah. Anyways, not very exciting. I'll fix that, and then I'm gonna jump off. Oh, what happened? But this was fun. Hope it was useful. We're gonna play some more with it, and I'll publish it. It's not many lines of code, which is also really cool. Like how simple it is. Like it's kind of crazy. One thing is the DevTools. That's complex, of course, but the only thing you have reactive, which is this thing. And then you have the proxy, which is, oh, well, yeah, it's 500 lines of code. So there is some code there, but a lot of it is related to the DevTools. And then, of course, you have MobX under the hood. So yeah, there's a lot of code at the end of the day. But at least transparency abstraction isn't that much code. It's like super tiny when it's in production. Anyways, that doesn't matter. Cool. Yep. Bye for now.